All right, well, good morning, everyone. Thank you, Chip, for that kind introduction. I think I now understand why people will say sometimes when they're introduced, my mother would be proud and my dad would probably find some ways to poke holes in what you just said, but that's okay. Good morning. Oh, come on, we can do better than that. Good morning, everyone. There we go. All right, so as Chip mentioned, it is my pleasure to be here with you this morning. I am the Deputy Division Director for the Division of Computer and Network Systems, or CNS as we like to call it, in the Directorate for Computer and Information Science and Engineering, CISE, at the National Science Foundation. I think we like big names and big titles and acronyms in Washington, D.C. But in any event, on behalf of all of my colleagues at NSF, Farnham Jahanian, the head of the CISE Directorate, Keith Marzullo, the head of the CNS Division, Susie Iacono, whom many of you have come to know over the last few years, Gracie Narcho, and Brian Lyles, from whom you'll be hearing in just a few minutes this morning. It really is a pleasure and an honor to welcome you to the 15th, I can't believe I'm saying it, Chip, the 15th GENI Engineering Conference here in Houston, Texas this morning. And to Dr. Bose and Dr. Gherkin, thank you very much for all the efforts and all your hospitality in allowing us to have this event here in Houston. Now, Chip mentioned, as he mentioned, I was up until recently the director of the Computing Community Consortium, the CCC. That's how many of you have come to know me over the course of the last few years. And it is really quite exciting for me to transition over to NSF because, among other things, I think it will allow me to be able to work even more closely with the GENI community going forward, and I'm really looking forward to being able to do that. Now, I unfortunately did not make it to the demo session last night. The hometown airline confounded my plans a little bit, but that's okay. But I have heard from Chip and others this morning just how fabulous it was and just how exciting everything is at this point, at where we are today. To be able to have end-to-end slices, to be able to have the experiments up and running, it really is quite breathtaking, and we're really thrilled with just how far things have come. You know, for me personally, my first introduction to the GECs and to GENI really was the 6th GENI Engineering Conference in Salt Lake City in the fall of 2009. And I have actually had the opportunity to go to every single GEC since, except for the last one. So that's 9 out of the last 10. And the how far we've come, really the road that we've traveled and where we are today is just absolutely remarkable. And I think it's a testament to the hard work, the dedication, and the perseverance of the GPO staff, as well as of all of you in this room, the GENI community. So I think we should give everybody in this room a round of applause for all of your hard work. Now, on behalf of my colleagues at NSF, I want to convey 3 quick messages to you this morning. First and foremost, GENI really constitutes to us one of our most important investments at the National Science Foundation. And the work that you're doing is extremely valuable as a consequence. Exploring next-generation networking technology and mid-scale computing research infrastructure and allowing at-scale experimentation is really critical, we believe, to our nation's economic competitiveness and long-term vitality. And I think we're starting to see that with interest by other federal agencies in GENI and what we're trying to do, as well as by the White House through some of our partnerships with US Ignite, which some of you have heard about in past GECs. And I think we're at a really great point right now as we move forward. Chip was telling us on a conference call last week the numbers of possible users or experimenters that we have, and it's just absolutely astounding. And I think that the growth potential is enormous as we move forward. Second, these meetings themselves, the GENI Engineering Conferences, are quite important in terms of getting the work done and in terms of continuing to move forward. I think when, in chatting with my colleagues at NSF who were there at the inception of the GENI project, when Chip initially proposed doing these conferences once every 3 or 4 months, we all thought, well, we'll see if that actually pans out. But here we are at the 15th GENI Engineering Conference, and so it's quite clear that we've come a long way in that sense. And that it's at these conferences that a lot of the hard work, a lot of the important discussions actually take place. And so I look forward to hearing those over the course of the next day or two. To those of you who are new to the GENI community, I recognize a lot of faces, and it's great to see that, but there are a few new faces as well. To those of you for whom this is your first GENI Engineering Conference, the GECs are really a great place to learn about GENI. And I think moving forward, they're going to be a great place to really be able to get your experiments up and running and really get hands-on experience with using GENI. And so I encourage you to take advantage of the hands-on tutorial sessions that are designed for both beginners as well as advanced users that the GPO and others have put together at this GENI conference. It's also a great opportunity, I think, to be able to engage with your colleagues and to make new colleagues and make new friends and potential collaborators, because after all, we have some of the best and brightest and hardest working networking and distributed systems researchers in the country in one room every time we get one of these GENI engineering conferences together. And finally this morning, I just want to express thanks again on behalf of the National Science Foundation to several different individuals. So this is going to take a little bit of time, but I think it's extremely important. I want to express my thanks again to Denise Gerken and her team here at the University of Houston for hosting us and for all of the local arrangements. Thanks to all of our friends and colleagues at the GPO, Mark, Heidi, Marshall, Henry, and the rest of the team. There's too many people now to be able to name in a short amount of time. Thank you to all of them. They've devoted countless hours, nights and weekends to making sure that all the systems engineering is done well, and most recently we're getting the experiments up and running and going. And somehow they're still able to find time to organize these GECs as well every 3 or 4 months. So thanks to them. Thanks to Chip. I think it's fair to say we wouldn't be here in this setting if it weren't for his vision and his leadership over the course of the last few years. So thank you to Chip. And again, just as importantly, thank you to all of you for your dedication and for really continuing to grow and cultivate the GENI community to get us to where we are today and to prime us for the future. So with that, again, on behalf of my colleagues at NSF, welcome. I wish you a terrific conference over the course of the next day or two. I'm looking forward to the plenaries this morning. I'm looking forward to the discussions, and I'm looking forward to the coffee breaks and the lunches where we get to continue to talk about GENI and its future. Thank you.
Well, thank you, Erwin. I think we're very, very lucky to have you in CNS. I wanted to take this opportunity to kind of take stock about, where have we come from, kind of where are we now, and then really to look ahead, because I think we've been, pretty much heads down, focused on what's going on, but I'd like to kind of take a bigger view about what's going on all around us. GENI began as a wonderful dream, and it wasn't the GENI Project Office's dream. It came out of computer scientists, professors across the United States. There was this incredible vision, and that's certainly what appealed to me. This is a slide from ever so long ago, right? The incredible vision of having an infrastructure where you could explore really kind of radical designs in how the future communications and computing is going to work in the world. And it had kind of, well, there must be clusters of computers in this and programmable backbones and, wireless and so on. So this was the dream, right? It was just a pure dream of, hey, wouldn't this be great if we had one of these things? And then you guys got to work. Right? I mean, so GENI is built by researchers, by the systems builders in computer science across the US, right? People just got to work and started building things. And it is really quite amazing, actually, how much has come out of people just, systems builders know how to build things. Got right to it and began building. And right now, the prototype version of GENI is so close, right? I mean, it's like we can taste it. This is exactly kind of the vision that there was some years ago, right? I mean, you know, all of us together have actually built this darn thing. Quite amazing. Maybe equally amazing, in the course of this, various GENI-related technologies have come up, and I think they're really starting to shake things up out there. OpenFlow coming out of Martine, Nick, and Guru at Stanford is clearly, I mean, this is an unbelievable kind of sensation that's going on in the world. I copied and pasted company logos who are supporting OpenFlow off their page. Rick McGeer, I'm sorry, you know, there's a little copying, pasting, the H section wasn't entirely there. It's a huge number of things. We haven't seen academic computer scientists have this kind of influence on the world in decades, right? So this is a really, really big deal. On the GENI racks, you know, we've not only got HP and IBM racks, but Dell is making GENI racks. Cisco, I believe, is making GENI racks. We have some indications, right? So we're starting to see the technologies that are bubbling up out of GENI really change what manufacturers are creating, what people are deploying, and so on. In the WiMAX and LTE space, it's a little less mature, though we've had great back and forth with NEC and Airspan. And now it looks like Bell Labs, this is early indications, but Alcatel-Lucent and Bell Labs will be in this mix as well. Can we create sliced, deeply programmable cellular systems, which are the edges of systems like this? We haven't seen this kind of impact of academic computer scientists on the world in quite a long time, in my view. Equally amazing, the cumulative number of users of GENI is going up at a very good clip. It's now approaching about 600 different researchers who have been using GENI to run their experiments and so on, right? So we're not only building this stuff, but we're exercising it, we're using it, we're doing research on it, and increasingly people are starting to teach their classes on it, which I think is going to be a very big thing in the coming years. The campus expansion is kind of an amazing success story. If you don't know Larry Landweber, here's a picture of Larry. Hunt him down and talk with him. He's one of the most interesting people around. He's got 65 or more campuses that are ready to go. The CIOs of these universities are ready to GENI enable their campuses. This is extraordinary, right? It's amazing that he's been able to do this. We are extremely fortunate that NSF CCIE funding is available, and more than a dozen campuses will simply get to work on doing this under NSF funding. Brian Lyles is going to tell us more about the CCNIE. But this is not a distant vision, it's going to happen someday. People are getting right to work on this stuff. And then from my perspective, we're seeing what I think of as kind of spontaneous GENI deployments. People say, well, heck, I have a little money, I can scrape something together, I'll put together a rack, I'll plug in, right? And so this is a sign that this stuff is really starting to take off. We are not an island in GENI, right? We're kind of the American part of what's going on really all around the world. And so we're seeing the earliest days of this kind of very new kind of sliced, deeply programmable infrastructure taking off all around the world. If all works right, we're going to see a great demo of the XIA architecture, Peter Steenkist's XIA architecture, running between the US and Japan. Last night you should have seen this also connected into Brazil, right? And so these connections are beginning to form, and we're starting to really see real slices all the way around the world and kind of increased uptake everywhere. So when I stop and look ahead, it's pretty clear to me, right, that GENI and the GENI-related technologies are gaining very considerable traction, right? A lot is going on here. This is a big deal. And if you look out 2 or 3 years, we really better have a plan for how this thing is going to grow out, because it's growing to a very significant scale. So that strategic planning is very necessary. Well, I know full well from my own life that both strategic planning and day-to-day operations are full-time jobs, right? These are actually both kind of hard to do. And so in my view, the time has come to separate these two functions, strategic planning and day-to-day operations of the GENI project. So I am going to transition on, starting now, to kind of looking out that 2-3 year kind of time frame. Begin that strategic planning and begin how we together are going to grow this thing to be really quite a large infrastructure, hopefully around the world. I don't know if this is an evolution of GENI or kind of, there'll be one more turn in the thing after GENI, but it's going to be the sliced, deeply programmable thing that we're all building together. And I'm particularly happy that Mark Berman is stepping up as the next GENI project director. Mark has been instrumental in getting lots of people to use GENI, make it usable, get people using it in their experiments, get classes doing it. So he's the perfect guy. So Mark now has overall responsibility for GENI's technical direction and for its successful implementation. So please join me in welcoming Mark to his new role as GENI project director.
The stage for a moment and say that when we heard that there was a new sheriff in town, a few of us decided that we needed to get together and get you some headgear that was appropriate for your new role and for our host city for this GEC. So, enjoy your new role.
I was hoping for one of these. I think it's a Texas thing that I don't thoroughly understand. Will you be offended if I take it off now, Rob? Okay. So good morning, thanks for coming. As Chip said, we're at a very exciting point in GENI right now. I think we're riding a very exciting wave of success, and I think our path for what we need to do next in order to maximize GENI's impact is relatively clear. So welcome to Spiral 5. This is a chart you've seen before with new goals. The things we need to do in Spiral 5 are reasonably straightforward. We need to continue deploying GENI resources so that we grow the installed available set of GENI resources for experimenters. That's racks, that's going out to more campuses, that's GENI enabling regional networks around the country. We need to build a clean, consistent, simple experimenter experience so that it's easier for people to use GENI for the first time. It's easier for people to continue using GENI as they build more and more sophisticated experiments, provide long-running slices and services. And the point of all this is to continue a steady increase in GENI use in the classroom and by experimenters. So, the tagline here, let's make GENI bigger, let's make GENI better. Bring your friends to GENI. We're already well on the way to doing most of these things, and I think most of this stuff will not be news to you guys. Okay? The first GENI racks are already deployed, and they're in use by people who are willing to cope with the occasional interruption. We intend to shift that to operational use over the course of this winter, and we are pursuing a very rapid and aggressive deployment schedule. 3 today, I'm out of fingers, but 17 by the time we get back together in Salt Lake City. There's one sitting at the University of Houston looking to be unboxed. There's one sitting at Ford International University, I believe, right now, and the only reason those things aren't being installed is because we're all here, but we're really going to step up the deployment pace. And over the course of the next year, 46 GENI racks. And this starts to be a very substantial down payment and a very serious step toward the kind of at-scale experimentation that GENI has promised. And as Chip pointed out, this will just be complemented by sort of spontaneous, commercially driven rack developments. Now we need to help support the commercial entities that are not necessarily affiliated with GENI who are putting together GENI racks, and we need to work to ensure interoperability so that we make sure that when these racks go out, they're actually beneficial to GENI and other experimenters. Excuse me. So we're taking these racks to campuses and regionals across the United States. I think this map is news, but this is the current planned location of the 40 some odd GENI racks. The green dots represent locations where we're currently planning on deploying racks, and Heidi, when she comes up and speaks in a few minutes, will talk about the arrangements we're making with campuses to make sure that they can support the rack deployments. The yellow dots are the next places we would like to take racks, assuming we can secure the appropriate funding. The shaded areas, or at least the shaded states, represent states served by regional networks where we have or will deploy GENI enable those regional networks. And when Brian comes and talks in a few minutes, he'll talk a little bit about the CCNIE program out of NSF and how that will help to accelerate and amplify these kind of effects. So we're making good progress on growing deployed GENI. And the next thing I want to talk about is improving the experimenter experience. We're at a pretty good point right now. And later this morning, Nikki Riga will conduct a demonstration called the Run a Complete Experiment demonstration. And the basic point of that demo is to prove that you can, in fact, run a complete experiment, soup to nuts, all the key steps of a real experiment using existing GENI tools. You should take this as a challenge. If Nikki can do it, so can you. Try your own experiment. There are a couple of opportunities to do that. We're holding an experimenter drop-in session this afternoon. If you are designing your experiment, if you're halfway done but you're stuck setting it up, if you'd like to talk about some ideas, please come by. It's completely informal. We'll have people around. We'll try to get you on the next step to a successful experiment. We also held an experimenter lifecycle tools session. This was yesterday. Jeannie Oren led that session. Jeannie, are you here somewhere? Okay, well, but that was a very useful session. We had a lot of good conversation on what the next set of tools are, and I'd like to invite those of you who have ideas about building GENI tools to come and contribute. You know, today using GENI is, a bit like a long stroll along a lovely country lane. You can use GENI. It takes a little while to get there. You will see some interesting things along the way. We want to change that so that GENI feels more like walking across the street. It's a very simple experience. Every time you use GENI, it comes out just the way you want. And no, we are not encouraging people to conduct experiments while sitting in the middle of the street. How are we going to do that? We need to make sure that we improve the consistency of GENI across different aggregates, across different aggregate types, and across time. But when I say across time, we're talking about reliability, availability, some control in the change of the platform that we offer up to experimenters. Marshall Bryn is going to talk tomorrow at the Experimenters Roundtable about trying to better define the platform that GENI offers to experimenters so that people know what they're building upon and know what they can count on when they bring up a GENI experiment. We're also growing the GENI toolset. This afternoon, you can come to the Clearinghouse and Portal session. You'll see a run-through of the current existing GENI Clearinghouse and Portal capabilities, and you'll be invited to join as early adopters. We're looking for a few people to help flesh out this capability, and assuming that the Clearinghouse and Portal work as well as we think, we'll be looking to grow that cadre over time with the intent of making it generally available in the coming months. For those of you who are building GENI-like entities elsewhere, the Clearinghouse and Portal code, we believe, are good ways to build a GENI-compatible, a GENI interoperable set of resources. We'd be happy to talk to you about sharing that code so that you can interoperate with GENI in that particular way. We had an instrumentation and measurement set of capabilities. We had, a session yesterday on this topic. And again, these capabilities exist now. You'll see them demonstrated during the Run a Complete Experiment demo. We're making great progress on having them be relatively simple for experimenters to use. They're currently rack specific, so the GIMI set of tools runs on ExoGenie, the Gemini set of tools runs on InstaGenie. Over the course of the next year, we're going to try to swap and blur those distinctions a little bit so that you can choose the instrumentation and measurement tools that best fit your needs. I'd like to recognize that the set of people in this room, as Erwin said, there really are two groups of people here. There are people whose faces are not as familiar, welcome. For the people who have been coming to the GECs and who have been using GENI for a while and are building up experience, we'd like for you to share that experience with GENI newcomers. And given that Ruslan is going to take us to a reasonably high level of literary reference with his talk in a few moments when he cites Kipling, I figured I should at least cite Hendrix and kind of drag the level down a little bit. But if you have a GENI experience that you're willing to share with others, I would like you to contact us at help@geni.net. We can help you to package that. We can help to make it available. We'd like to show other people how you've been using GENI and hope that inspires others to figure out ways that they can use GENI more successfully. So why are we doing all this stuff? Well, we're doing all this stuff because we're looking to increase uptake of GENI in the classroom and in the lab. Fortunately, we're riding a wave of success here. GENI's already spreading to more campuses. Many times that's because we're taking it there through a GENI deployment. But campuses are, as Chip said, spontaneously choosing to deploy GENI and GENI-like technologies. We're witnessing tremendous uptake in experimenter use and beginning to see solid growth in the classroom. I'll show you some statistics in a second. We're seeing commercial adoption of some very important key GENI enablers. OpenFlow, GENI racks are the poster children for this one. And GENI is starting to become more and more visible in the academic literature. If you visit the GENI bibliography section under the GENI wiki, you'll see this little site icon which will take you to the bibliography. We'd like to make sure we're including your stuff. So if you're publishing and you're using GENI or you're building GENI, please let us know, send us a copy of the paper, put GENI in your keywords, we'll make sure it gets included in the bibliography. Another way we're seeing GENI take off is with growing international collaborations. These collaborations are based on federation, they're based on equal relationships, and they're based on interoperability. And these are really wonderful opportunities to connect some of the best researchers worldwide. When you see Ruslan come up and speak, when you see Aki come up and speak later this morning, when you see folks connecting to networks in Brazil, these are all invitations for you to build collaborations. So if you see something that triggers your interest, grab these guys. They're here because they want to start collaborations with this group of people. This is the graph Chip showed a little bit ago with the number called out in bold. Sometime this past weekend, we hit 583, which was the target we were shooting for. Unique users. And this is just actually in proto-GENI resources. It's just the one we have best instrumented right now. But this is very exciting, and we want to see that line continue to, well, we'll have to change the scale for the next one, but we want it to climb right off the top of the graph. How are we doing that? We're doing that by having a number of programs that help to train new experimenters. Kai-Chi and Bing are here representing the GENI Summer Camp and Experimenter Workshop program. The next GENI Experimenter Education Workshop is in Salt Lake City in conjunction with the next GEC, GEC16. The paper deadline is January 3rd, so you have plenty of time to get your experiment together and submit a paper on that. Ray Chowdhury will be giving a keynote address there. We have a summer camp planned at the University of Connecticut for June of 2013. The theme will be using GENI wireless resources, although experiments in any area are welcome. There are flyers for both of these out back at the registration table or at the GENI help desk. Please, if you're interested, if you'd like to send a student, if you'd like to come yourself, pick up a flyer and be in contact with us. We're also conducting tutorials. There are a lot at this GEC. We're conducting tutorials at non-GENI conferences, so we can stop just reaching the folks who are here. And we're starting to conduct GENI tutorials with a little traveling roadshow on campuses. If you have interest in having a GENI tutorial on your campus, help@geni.net. If you have a tutorial that you're giving here or a classroom example or some other piece of tutorial material that you're ready to make available online for other GENI users, please, again, get in touch with help@geni.net. We'll help you package that so that people can use it regularly. There are a number of examples already online, including a new Hello GENI example, which is designed to be the canonical first GENI experiment. Classroom use is picking up very well. Over the course of last year, we had at least 3 classes taught using GENI as a significant component of their curriculum. There are 2 ongoing this semester. Rudra Dutta, who spoke about some of the challenges in yesterday's experimenter tool session, is teaching a class, and Christos Papadopoulos at Colorado State. These guys are moving ahead, and we expect at least 4 that are in the planning stage for this coming semester. These guys are having, I think, great success building on some existing curriculum modules that Sonia Fahmy and Ethan Blanton at Purdue produced and put online, and we intend to grow that. Again, we invite you to help contribute to that effort. So we've got a bunch of ways going to train the new GENI experimenter community. We're supplying a better experimenter experience for our GENI experimenters, and we're growing the set of available resources for them to build on. This is, I believe, a clear path to continued GENI success. Thank all of you for your contributions to moving this along. GENI is going to continue growing and succeeding because you folks are here making GENI bigger, making GENI better. So Heidi's going to come up and talk in just a moment about our deployment progress. I'd like to just introduce the remaining plenary speakers for this morning. After Heidi finishes, Brian Lyles will come and talk about NSF's CCNIE program. Ruslan Smilyansky from Moscow will speak about, he will cite Kipling with his GENI We Be of One Blood presentation. And Peter Steenkist will lead a discussion of, a presentation on the expressive internet architecture. This is one of the Future Internet, FIA Future Internet Architecture programs, and we'll have a demonstration. We'll take a break. We'll be back. Justin Kapos will talk about a sister program using the Seattle testbed and how he's had great success using Seattle in education. We'll have a couple of presentations of ongoing and GENI research. Ashish Villamuri will talk about some of his results in using using redundancy to reduce latency. Prasad Kalyam will talk about their virtual desktops project and how they've been using OpenFlow there. And Nikki will show the Run a Complete Experiment demo. And then we'll see a couple of international collaborations. Joe Mambredi will talk about the slice around the world. And Aki Nakao will show a federated vNode and GENI packet caching demo between the US and Japan. Thank you. We have a very busy time. We're making great progress. It's an exciting time to be working on GENI. Thanks.
Okay, My name's Heidi Picher Dempsey. I'm glad that you all are here working on this great integration and deployment project from my point of view. I'm glad you had a good time last night seeing all the successful demos and the working network because we're doing our best to break it in the next few months. I'm going to give you a 10-minute summary of what's going on in the infrastructure. There'll be a lot more detail if you're interested in the racks and the networking. Come to the campuses and racks session, and if you're interested in WiMAX and wireless and how that ties in, come to the WiMAX session this afternoon and you'll hear a lot more. So to begin with, there's been a lot of activity with the regional networks. I'm going to go through the different pieces and show how they go together. Spiral 4, which is just concluded, we did, as we expected, find some issues with integration and with some of the releases of switches that we were using. But all of the regional networks that were part of GENI are up and running and successfully running the GENI aggregate manager and the layer 2 OpenFlow infrastructure. So that's great progress. And in Spiral 5, we're going to expand that with more switches, more campuses, and more racks. We had a couple of bits of bad news. They're not too bad, but you know, not everything goes the way you want. UEN is putting some of their layer 2 infrastructure, UEN is in Utah, and they're putting an interesting OpenFlow switch into a data center, and there were some facilities delays with getting into there, so that didn't happen. But the integration with the Proto-GENI and UEN is going very well, and we were actually able to show some of the interoperability working for network end-to-end connectivity for that. And then some of our sites are using Brocade software, and there was a delay in the general availability release for Brocade. And some of the features that we really counted on for GENI were not there in the early versions of that software. So that kind of slowed down some of the integration at CNIC and CanRen. But again, they're up and running, and we're working around things that aren't quite the way we want, and it's going to be open to experimenters soon. So the good news is some of these regionals are actually up and available to experimenters already, and you saw probably some of the results of that last night, or perhaps today. And we've got 2 new regionals joining the effort. NYSERNet is implementing infrastructure right now, and they've been attending our regionals calls and doing planning with us. And Max, which has been involved with GENI for a long time, is coming back in at great guns and going to be very involved with the stitching effort and using their already deployed open infrastructure to be part of GENI. And we've also just gone through and upgraded all of the FOAMs, and FOAM is the aggregate manager that does OpenFlow in GENI, and all of the shared monitoring successfully, which is a time-consuming thing to get all of these people to agree to do it and then work through all of the installation and testing and integration efforts. So I'd like to really thank all of the regional people who helped out with that and the GPO staff people who made it come together. And I think it's going to be really great to see shared monitoring with lots of owners actually working in GENI. If you want to follow whatever the latest updates are, we do this publicly on the regionals webpage on GENI, so check that. In the core networks, we have 2 core networks that we use for GENI, Internet 2 and National Lambda Rail. National Lambda Rail had planned to expand the GENI OpenFlow mesoscale, and due to some reorganization at National Lambda Rail, that didn't happen in Spiral 4, but they're committed to doing it in Spiral 5, and they're working on it actively now. And on the Internet 2 side, Internet 2 has announced that they're going to add 10 gigabit paths to the existing mesoscale so that we can build VLANs that will go between the mesoscale and the advanced layer 2 service in Internet 2 at 4 out of 5 of our POPs. And those POPs are also the places where the Proto-GENI nodes are that sit in the mesoscale backbone. And so you'll be able to create experiments that will stitch together pieces of the advanced layer 2 service, Proto-GENI, OpenFlow, mesoscale, and GENI racks, and that should give people the opportunity to do some really interesting things that we hadn't been able to do and have some more interesting topologies that weren't possible a year ago. Internet 2 is also working on running a GENI aggregate manager, so that can all be seamless, and they're expecting to do that as part of our Spiral 5 work too. So I think most people in the room already know what GENI racks and campuses are trying to do. If you don't, then come to the session this afternoon. But the main advantage of having a GENI rack in our mesoscale infrastructure is that there's an API that you can program to so that it can be consistent for how you get your resources. Racks can specialize and offer things beyond that, but at least for the basic access and credentials and stitching together of resources, that's in an API. So if you want to do a tool, or you want to run an experiment, or you want to come up with an application that takes advantage of the dynamic networks, there's an interface to let you do that. And it'll be a lot easier for us to make that consistent and operating continuously with the GENI racks in place. The R specs, we're supporting version 3 in the GENI racks, and both rack teams are committed to evolve as the R specs are approved in the meetings that we have here for general release in GENI. And the racks all federate with the slice authorities that are in GENI, and there are 3 main ones right now. There may be more in the future. So we have some deployed racks in testing already. These are the pictures of where they are: Utah, North Carolina, Cambridge, and some of them which are not quite racks yet. Florida International. This is a day-to-day progress of building the mesoscale. So literally yesterday and probably this afternoon there'll be changes in the status. So do follow the links that I put in here if you want to find out where things are on any given day. This is a very wordy slide that just describes how we plan to deal with the fact that we're going from 3 racks in testing to almost 50 deployed over the next year and working together. Obviously, in order to do that, we have to progress from the rack teams, which started everything and built everything themselves in sort of, coming to these meetings every few months and telling everybody else what was going on, to a joint engineering and network deployment effort and testing effort, which we're in the middle of right now. And we're starting to involve the campus network engineers and the campus researchers. I'm only talking about the deployment part. Of course, Mark has been involving them all along, but I'm the one who asks them to do the hard and not fun stuff usually. So we transition to that piece. And then finally, at the end, we involve the operations support people, the GMOC people who are actually running experimenter help desk and running monitoring and doing some trouble ticket tracking and escalation for us. So that's the general idea. This is the schedule of record as of today. So, every few months we deploy a few racks. No big deal. If you want to hear more about where they are and how this is going to happen, we'll talk about it this afternoon. This is the map you already saw. And again, this is negotiations ongoing, so track on the GENI wiki if you want to see the status of any one of those little dots and whether it's green or yellow and whether it's connected or not, or whether it's lost somewhere in transit. We have a list of things that we expect from people who get GENI racks, and I put that in here because a lot of people come up and say, what do I have to do to get a GENI rack? So you can build one yourself. You can get one from the InstaGENI team. You can get one from the ExoGENI team. And if you have it, you need to support it and keep it up to date. And so these are more formal ways of stating that. But this is basically, if that's your question, this is how you go forward. We have a lot of other integration efforts going on besides just the deployment of GENI racks and the integration of the OpenFlow and mesoscale networking. I'm concentrating a lot on that, but these other efforts are critically important too, and other people in GENI are helping to make sure that they keep moving forward. Joe Mambretti has been making sure that the layer 2 infrastructure reaches outside the United States and that the slice around the world continues to function. This is not just a demo. This has been up and running for a while, and we expect it to continue running. So that's very exciting. Peering agreements are starting to be formed. So people who own their own networks and want to describe how those networks can interact with GENI in some way that you could write tools for, or you could write policies for, or you could actually see turning into a worldwide GENI internet, those are starting to happen. And Jim Williams has been helping a lot with getting those people together and making sure that we have chances to discuss how that should happen. Some vendors are starting to get involved in the idea of building GENI racks. So Dell is actively on the scene. They were here last night at the demo session. They're working with Clemson, and we're hoping to see those coming into the mix soon. Cisco is also interested and has done SDN announcements, as I'm sure you know, and we think there will be some interesting possibilities there. And the Quilt, which is an organization of regional networks, did an RFP so that people who weren't already involved could look at what their colleagues in R&E recommended for OpenFlow switches, as far as what types would you like, what would their configurations be, how would they interact well, what could you do with them, and then some nice purchasing programs for members. So Jen Leisure, who couldn't be here today, has given me some slides, and I'll be posting those on the wiki for more information about that program. I know nobody can read this slide, but I want to point out that there's been a lot of progress in monitoring happening in the last few months. We are able to look at virtual machines, slivers on racks, foam aggregates throughout the country, all of which are owned by different people, all of which are managed by different people. They're running on different hardware. There is no one central owner or operating center for any of these, but you can look on the web and you can see at any time you want what's the status, where are the slivers, who's doing what, and that's an amazing amount of progress for GENI in a short time, and I think one of the few networks where you can actually make that kind of a claim. So it's been very hard fought, and I'd like to especially thank the people at Indiana University and the GENI staff who spent long hours trying to integrate the software and make it so that I could put up these slides today and tell you, hey, it's working. And we'll probably break that too in the next few weeks. Finally, the production support for the network, we're continuing to expand and try to make it easier for people to get set up with GENI, ask questions about GENI, call somebody, or send an email to somebody to fix a problem if you see a problem or just aren't sure how to use things. So those things are all still available and starting to get more frequently used. And the GMOC is stepping up and doing some more online monitoring and online escalation, emergency stop, things like that. And I think you'll find that that will help make the GENI experience a little easier and more pleasant in the year to come. So thank you all for your tolerance and your help if you've integrated any of these pieces, and look forward to an exciting Spiral 5.